All right, page 259. All right, this is very similar to what we did yesterday. We looked at the fraction bars and circled, for example, 3/7 plus, how many are here? 2/7, right? And there's 7 equal parts to make up one whole. So to complete the addition equation, we would just put 3/7 plus 2/7, but this time it does not equal 7/7, does it?
It equals 5.
So we would put 3 plus 2, and that is equal to 5. So this time we're not looking at it as one whole, we're looking at it as parts of the whole. All right, so here we go. Write the numerators to complete each addition equation. We've got 3/9 plus 4/9, which is 3 plus 4 for the numerator. Our denominator always stays the same when we're adding or subtracting fractions. Well, this is just, there we go. Whoa, whoa, it's crooked. Okay. There we go. Okay, so 3 plus 4 is? See, this isn't too hard, is it? Yeah, I told you it wouldn't be so bad. And again, 1/5 plus 3/5. So we think to ourselves, 1 plus 3 is 4. And notice, again, our denominator always stays the same. Whenever you're adding and subtracting fractions, you have to have what's called a common denominator. Okay? That means the same denominator in all of the fractions. All right, 2 plus 5. Bam, bam. There we go. How much is it? 7/8. So what happens to the numerators in each equation? What do we do with the numerators? We add them. Simple. And what happens to the denominators? They stay the same. Whenever you add or subtract fractions, the denominator has to stay the same. And if it's not, guess what? You have to figure out how to make it be the same. Yeah, and you guys are going to learn how to do that too, but not right now. Because there's different ways to do it, and we're going to learn that. Okay, so how do you feel about this so far, guys? Not too bad, right? Okay, let's look at the bottom. Subtracting fractions this time. Yeah, it's easy. The circled and crossed out parts of this fraction bar show a subtraction problem. So let's look at what's circled first. How much of it is circled? 1, 2, 3, 4, 5, 6 out of 7, right? So that would be 6/7. Now how many are x'd out? 2/7. So we would say 6 take away 2 is 4. And our denominator stays the same. Yep. Easy. Yeah, no problem with this. Okay, now we're going to take a look at the back side of this. We're going to do a little bit more practice. This won't take us long. Okay, so we've got 5/6, take away 4/6. So we change that to 5, take away 4, and we know that that is 1. So 5/6 take away 4/6 is 1/6. Okay, keep on trucking. You guys can do this. What'd you get for number 9?
5. No, 4.
9 take away 5 is 4, but that's not the answer. It's 4/10. Okay, now we got 14/16. Take away 9/16. 14 take away 9 for the numerator, which is And the 16th stays the same.
What are 16?
16ths are when we would, if we would have folded our eighths that we had in again, we would have had 16ths. They're really tiny. So if we look on a ruler, on the inches side, let me see here. If we look on this ruler on the inches side, we have from here to here is one whole, right? This is one whole. If I divide it up into fourths, 1, 2, 3, 4, that's fourths, right? Are you looking, Nova? You asked the question, I'm showing you. Now, if I divide each of those fourths in half again, which is right here,
8. That's 6.
now how many equal parts do I have up there?
8. No.
1, 2, 3, 4, 5, 6, 7, 8, right?
Yeah.
Now if I divided those up one more time, and see how they're lining up with these tick marks on the ruler?
Yeah.
1, 2, 3,
That's 16.
that's 16ths.
That's
So if I count all of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So each of these little white marks between 0 inches and 1 inch is a 16th.
wow.
A 16th of an inch.
Wow.
So when you really want to be precise as a carpenter or whatever it is you happen to be doing, and you want to measure to the nearest 16th, that's pretty precise, isn't it? Yeah. So there you go, there's your answer. 16ths. Okay, back to number 11. What happens to the numerators in each equation?
They get subtracted.
Okay, they get smaller, right? Or we could say they are subtracted. And how is subtracting fractions with like denominators similar to adding fractions with like denominators? The denominator always stays the same, yeah, in both cases. And we call that a common denominator. They have the same denominator in common denominator. So when I use that term next time, you'll be like, oh, I get what she's saying. Okay, do you guys want to try practice down at the bottom? They've got it written horizontally and they have it written vertically. We can do one of each together and then you can try it on your own and we'll correct it. Sound like a plan? Okay. My hard workers. All right, let's take a peek. We got 1/4 plus 2/4, so that would be 1 plus 2. And that would be equal to 1 plus 2 is 3, and our common denominator is 4. Done. All right. So when we look to solve these vertically, you don't even have to do that extra work up here if you don't want to. You can just go, 7 take away 5 is 2, and my denominator is going to be 9ths. So my answer is 2/9. Right? Okay, you guys take a little time to do that. We'll come back around and check it. Okay, so Ashley just said that number 17 doesn't make sense. Okay, it does though. I'm gonna show you. Even though we've got 2 plus 4, that's equal to 6, right? And 5 plus, or I'm sorry, we don't do 5 plus, and the denominator stays the same.
Yeah.
This is called an improper fraction.
Yeah.
So this is still a fraction. And we're actually going to learn, next week, we're going to learn how to make that into a whole number and a fraction called a mixed number. Okay? So we'll turn improper fractions to mixed numbers and back and forth. So, good question though.